Okay, well, good morning, everybody. Glad you could all make it to what is called Benjamin's Bar. There's not a bar in here, but anyway, there could be, I guess. Looks like a good room for a bar. Anyway, so I hope you all enjoyed the keynote. I did. I learned about diversity, which is good. So since there are 3 women in the room, that means we must have our intelligence upgraded by a lot, I guess. Actually, I have 3 in my team, which is about 30 people. I have 4 women, so that must be a very intelligent team, I guess. Anyway, the stuff I will be telling about this morning, which is totally different from the stuff I'll do tomorrow, because that is much like Alan's second part of the keynote, just a bit, like only I have 1.5 hours to explain that, and he only had like 40 minutes, so that's good. It's a bit about service-oriented architecture. It's a bit about design, about modeling, and since this is an architecture conference, much more than a developer conference, so I'm going to show you some models and some architecture stuff, and maybe some code as well. I don't. Oh, that's me, I guess. It's a bit too loud. So just by show of hands, who of you actually programs? Because I haven't got a clue what it does on an. Oh, that's good. That is a very good percentage. It should be 100% though, but anyway. So I can show code, right? That's good. That's basically good. Okay, good. So here we go. So let me introduce myself first. You all have a picture of me, by the way, because I am on the back of the brochure, which is really good. I just found out this morning myself anyway, so that's me, the small figure on stage, not me in the audience. That's a different talk, but anyway. So this is me. I have a stupid name to pronounce in English. It's in English you would probably say Hoogendoorn or something. And I'm from the Netherlands, and it's pronounced Hoogendoorn. That's what you do in Dutch, right? You do the etc. I am, basically I'm a dad. I have 3 kids of my own, and my girlfriend who's in the back has 2, so together we have 5, which is, it takes some time in your life, and I get to spend less time to program. And so I'm also a programmer, trainer, coach, architect, blah, 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 whatever. And I will start as an independent consultant as of January 1st. And I'm doing training courses all over, etc., etc. I've written some books. Basically, my current occupation is I am working for Capgemini. Basically, for those of you who don't know Capgemini, it's a large company. I think we employ about 140,000 people worldwide. So in the Netherlands, we have this huge office building, which is right next to my house, actually. I can actually walk there. And there's usually all those people showing up in the office saying, "Ah, this is a big office. How many people work here?" And I usually say, well, about half of them. And I'm also a member of what we call the Global Design Authority, which means basically I get to travel around a lot and talk to people about Agile around the group, etc., etc. So the next trip will be Casablanca, which is basically good, although I like London too. And I recently started, well, as of January 1st, to work for an insurance company. Basically, the story I'll tell you today is about this insurance company. They sort of made me like chief technology officer. They didn't have one, so they were looking for one, so they made me that. And this is basically my personal website. This is my Twitter tag if you feel the need to tweet about this stuff. Also, Chris asked me if you could somewhere fill in the application evaluation stuff, and it seems to be pretty easy. Just go to the app, go to my talk, and the slides are also there. Basically, it's the same set I'm using today, so that's pretty good. Usually I sort of change them in the last minute, but I didn't do that this time. Oh yeah, some of my books. Basically, there's nothing for you in here because these 2 are in Dutch. This one is in German. Doesn't help, right? But luckily for the Agile book, there's also the English version, which you can buy on Amazon, and I'll give you a discount code at the end of the talk. If you're still here, there's a discount code on the slide deck. So, oh yeah, about being a developer, because I write code as well. I do that on a daily basis, usually in pairs and stuff like that. I'll tell you a short anecdote on that, and then I'll leave you with that. I was working for the Dutch Social Security Agency, and they have huge COBOL installations. They're actually huge, like 100 million lines of code, right, in COBOL. So and they will never get rid of that. So they said, okay, they tried to, by the way, it was a project, costed over 150 million euros. It failed, as large projects usually do, right? And then they said, you know what, we're never going to get rid of this, so we're going to build services on top of this COBOL stuff, and then we'll build web applications on top of that. So we started doing that, and I was testing some JavaScript, just to make sure that people wouldn't leave the page they were entering data on. And then we had a project manager, and sure, as you listen to Alan, you don't need one. I think you don't either. I agree with Alan on that. And but there was one there, and in all his wisdom, he decided to do a demo to the CEO of the Dutch Social Security Agency. And about an hour later, I got an email from him saying, a question saying, with a screen grab saying, "Are there any more of these message boxes popping up?" I said, well, I don't know, actually. That's what you get for demoing non-tested code, right? You shouldn't be doing that. So, this is the agenda, by the way. So I'm going to talk a bit about microservices, as that seemed to be the latest fad, and I love it, by the way. It's great stuff. And the trouble with it is, it has a lot of promises. And if you read the blogs and et cetera, on the internet, there seems to be a lot of promise in doing microservice architectures. And there actually is. I can assure you. But it takes a lot of things to find out. And as you look to new hypes on microservices, you could consider that a new hype, although the evangelist saying, oh, it's been around for years and years and whatever, but there are some technology changes and some technology challenges in there that you have to deal with. I'm trying to elaborate on that a bit. And I'm trying to explain what this particular insurance company comes from, right? What their current state of software development is and their current state of their applications. And then I'm going to try to show you how we moved away from that, or how we are moving away from that, to be more precise, because, of course, we're still doing that, and we will be doing that for years and years. So that's basically it, and I'll talk a bit about how to model that stuff. So there's no way in saying this is the way to model it, it's the way we model it. It's a technique we've been using for a long time now, and it nicely fits into this microservices thing if you want to talk about requirements. So I am going to do that, and I'm going to talk a little bit about Agile, if there's time, but I really don't have a clue on where I'll be through my time, where my time box is finished, probably somewhere here. So I have to hurry this one, but I will come back to that tomorrow. So that's it. If you have any questions, just shoot. First of all, I have to say that it's very tough for me to stay within these architectural boundaries that I have here on the floor. Basically, it's because we're being filmed, and I have to stay within this rectangle. So for me, that's a really tough thing, because I'll have to walk around a lot. So, but I'll try. So if I get out of the box, please show me back to my box. So microservices, right? There's a lot of stuff to say about microservices. And it's actually, I think it's a good thing, basically. Because, oh dear, I want to step out of the box already. I have to point like this, right? So back in the 70s, I don't know, in the 90s and the 80s as well, I don't know, when did you start your programming career? Right? Well, I started programming in, I think, 1986 or something, professionally, right? Making money out of programming. So it's been a long time. So I've seen this, literally. And some of you might have seen this too. I don't know what your age is. I'm 47, so I'm probably one of the older ones in the room. Anyway, we programmed a lot, and basically it was one big thing of code and all hooks together, and everywhere there's links and dependencies, basically dependencies, which made it very hard code to maintain. And then we started moving slowly into something called, first it was called component-based development back in the 90s, and we had huge processes to implement component-based development. I spent like 2.5 years at a bank in the Netherlands, an international bank, just describing their approach or the methodology to do component-based development. Of course, it never took off, because if you spend 2.5 years describing a process, well, implementing it costs at least 5 years, and then component-based development wasn't hip anymore, right? So we started splitting up things into components, but these components were still quite big. And now we moved into the era where each of these components, each of these very small components, is getting smaller and smaller. Some say they shouldn't even cross more than 100 lines of code. By the way, it's really tough getting something done in 100 lines of code these days. So, and they're all very, very small, which means that if you move to a landscape like this, and you would be able to, let's say, deploy each and every one of them individually, the maintenance costs will go down a lot. That's true, basically, but there's a lot of decoupling to do. So I'll show you later what the landscape looks at my current client and where we are. So we are moving from this to this to this, basically. And it's a learning process. It's not something you can do overnight. It's not something you can say, okay, as of tomorrow, we're going to do microservices, and then everything changes. Well, it does, basically, but there's still a lot of code out there that you already have in place if you work for a larger company, such as I do. So, yes, we are moving in this direction, but it's a very slow move. And there's lots of stories about companies that already are doing this successfully. Yes, there are, but there's a lot of stories out there about companies who are trying to figure out how to do this. And the company I'm working for is one of those companies. We are trying to figure it out. And it seems to work, but we aren't there yet. So, let's look at where we are at microservices. If you read the blogs, and you probably all have, because you're sitting in this room, so you're probably all wondering, what's this microservices stuff about, or you're already doing it. And if you look at the literature out there on the internet, it's basically describing, oh yeah, there's this microservice architecture pattern now, and we are using it, and it works for us. And then you think, okay, how are they doing that? And then the blog stops. Just as you try to get the answer questions, how do you do this in real life? There aren't any answers yet out there in blogs on the internet yet. Basically because this is new stuff. So people are first saying, okay, yeah, this is great stuff. We should all be doing this. And there's lots of stuff out there that says that. But you get these questions like, when is a service a microservice? Do we really care whether a service is actually a microservice? What's the conditions of something being a microservice? What's the definition? Well, there isn't one. At least I haven't found one. You could make one up yourself. That's good. But it's very hard to decide on that. There's people saying, yes, it has to be no more than 5,000 lines of code. I've also seen definitions that say no more than 100. Is there a difference? Yes, there's a big difference. It has at most 5 endpoints. Well, I could say that goes for most of the components we have now. It also says it's JSON over HTTP. Why? Well, it could be. We're working with that, and it works, but there's lots of stuff to figure out on that one, actually. And microservices in a nutshell. Of course, Martin Fowler always comes into place when talking about microservices because he blogs about it a lot. But again, if you read his blogs, there are no solutions in there. There's just, in most blogs, a lot of questions about what this stuff is about. Or at least somebody saying, yeah, it works for us. Or people say, yeah, you should all be doing it. Yeah, why? And when and how? Well, those questions aren't usually answered yet, which is quite normal as it is quite new, right? And you see there's even books already. I don't know if the writer is somewhere here near, but it's an early release, so it will probably change. So people get on the bus already writing books about it. And if you write a good book or write it now, it sells amazingly. Much better than books on Agile these days, I can tell you. So, and there's also conferences already, which is good, right? A whole conference based on microservices. But there will be more, I guess. This is the first one I saw, actually. It's actually right here, right? It's in London. And it's next month. Although it's fully booked. So, I don't know if any one of you is going here. Is anybody? Because you're all here, right? You cannot go to 2 conferences in about a month's time. Unless you rule your own budget, right? As Ellen said, right? So there's lots of stuff out there, but there's no solutions yet. Well, I like this definition. This is the ThoughtWorks definition. I just got it off their website, just as the following pictures. And they say, well, in short, the microservice architectural style is an approach to developing a single application. Well, it doesn't have to be a single application, by the way. We are developing micro applications as well. We started doing that. As a suite of small services, each running in its own process and communicating with lightweight mechanisms, often an HTTP resource API. That's fairly simple to do. So these services are built around business capabilities. That's the tough part, by the way, about this. And independently deployable by fully automated deployment machinery. Says who? Well, to tell you the truth, I would really love to have this in place, my fully automated deployment machinery. But to get that in place in a standing organization is a bit tough. Because we have people in the organization who are responsible for application maintenance. And they're not on my team. They want to be on my team, though, but they're not allowed to because they have other stuff to do, right? So setting up this fully automated deployment pipeline is not as easy as it looks. They have all sorts of demands on the stuff we're delivering before we can actually deliver it. Like there has to be some sort of documentation. There has to be versioning. There has to be stuff about if we use a database in this component, what does the database look like? They want to own the data model. So we are now using MongoDB for a number of these databases under these components. They haven't got a clue to work with that. So what's the data model on this database? Well, there is no data model on this. You just have collections. There are no tables. There are no keys. There are no relations between the tables. It doesn't exist. So how do you deal with that? Well, they don't know. We don't know how to migrate it into their environment yet. So we're still trying to figure that out, right? So, and there's a bare minimum of centralized management of these services. I wish there was. Which may be written in different programming languages and use different data storage technologies. The last one, I can actually say this is true. That works a lot better. But writing in different programming languages, if you have, I have a 32 people team now, which will grow to a 40-person team in the next months. And most of them write Java. Some of them write a little bit of JavaScript. None of them write C#, except for me. And so writing in different programming languages, yeah, you could possibly do that. But having multiple programming languages means you actually have to have the JVM in place, or the Java runtime, or a JBoss application server, whatever you might have. And also, if you want to run .NET, you have to have .NET as well installed, which means a different runtime, etc., etc. There's not a lot of, only the very, very big companies actually do that. Most of these choose either the runtime, the Java platform, or the Microsoft platform, or they go for pure JavaScript with Node.js or whatever they do. So it's not always the case that people, it looks fun, right? You can write in different languages because they're all services adhering to some REST API. That sounds nice, but having all these languages in place makes application management later on in the cycle much more difficult, right? So this company decided to stick to Java, which is fun to me because I've been doing .NET projects. I've been writing C# for the last decade or so, and then I got back into Java during the first. It's like going back to the Stone Age, right? There's just so much stuff in C# which is not in Java and will never be in Java. Like we now get streams in Java 8, right? Do you all write Java, by the way? Oh, only one? Wow. So what are you writing? Who's of you is writing JavaScript? Who of you is writing, what else would you have? C#? Oh, good. Oh, good. I love you guys. Oh, so I can make jokes about, sorry about for you, but I can make jokes about Java. You know, Java is, the platform is quite okay. So there's a lot of stuff in there. But as a language, it's been dead for at least a decade, right? It hasn't evolved. They get streams. So you saw that in the keynote from Neil. They now have streams, right? Streams is basically the poor implementation of LINQ. We have had LINQ like how many age? Like 8 years already? I forgot more or less. So they now have parallel streams, going to get that in Java 8 as well. We've had that in LINQ for like 3 to 4 years, right? If you look at a simple thing like generics, for instance. So generics has basically been in .NET like since version 2 or something, right? There's generics in Java, but it's only design time. At runtime, the runtime doesn't really know what the T really is. It hasn't got a clue. It's just an object. So on runtime, there's no generics in Java. It's a very poor implementation. Lots of other stuff, like extension methods. Well, when I first started using extension methods, like, I don't know what, 8 years ago, it was like, what is this? And then you started getting used to it, and it's so normal to do that. And when you have to move to Java programming again, they're not there. They don't have that. So it's a very poor language. Anyway, the platform is good, the language is poor. So, but it's a readable language though. You can, if you write C#, you can also write Java. That's not an issue, right? You just have to put the brackets in the wrong place. And it sort of works, right? And everything which is a capital, you uncapitalize it and stuff like that. I still write the toString method with a capital T, and I say, oh, it doesn't work. Oh, right, it's a small t, right? Oh, yeah. Oh, I have to remember that every time again. Especially since I'm also still doing .NET projects. But anyway, so the microservices stuff again, right? Usually, if you talk about scaling, if you have to move to larger audiences, what people usually do if you have a monolithic application is you spin up multiple instances of this big application. So instead of one, by the way, I stole this picture from Martin Fowler. I stole the next one as well from Martin Fowler. But it's a good picture. I don't have to redraw that. It's just reuse of pictures. So you just spin up 4 instances of the same thing. Whereas if you can move to an architecture that has a lot of very, very small components, you could just say, well, you know what? This is the component that actually gives us the biggest stress. So we're going to just spin up a couple of instances of this particular component, which is far more easy than spinning up multiple instances of a very big application. So yes, it works for scalability. It actually does. Also, I like this benefit of doing microservices. This is, by the way, Neil Ford had the same picture in his slide deck, only he cut it in half. The thing is, if you have a big application, it usually sits on top of a database. And it is quite usually a relational database, such as an Oracle database, a SQL Server, or in my particular company, a DB2 database. Everything sits in relational databases, even if a relational database is not the best structure to do that. Let me give you one example. So I'm working for this insurance company. We're now building a piece of software that actually people can request for life insurance policy. So, this request builds up, right? You go through a wizard. So there's a number of steps you can take. You have to fill in the amount you want to insure and whose life is insured, etc., etc. So it builds up. So it's like the wizard consists of 10 steps. And during the process, people have to be able to say, oh no, I'm going to save my request now. Which it's not an HTTP request. It's a request for, is there a better word for that? You probably have it. If you go get a life insurance, what do you fill in? You have a form basically, but an application, right? That's the word I was looking for. But application is a bit hard if you talk about application. So anyway, an insurance application, and you fill it in, but you want to be able to store it halfway. If we're halfway through the wizard, the thing isn't completed yet. So it misses, so it's an aggregate with a lot of domain objects in it, and it misses about half of the domain objects. So if you want to move that into a relational database, how do you do that? Because you get a lot of these constraint violations from the database saying, oh, this one isn't there, and I need this as a foreign key in this particular table, etc., etc. Doesn't work. So we couldn't store it in a relational database. Now, in this particular company, the CEO of the company is very much involved in our software development. In the previous project, before I got in, he was the one, so it's the CEO of an insurance company, right? He was the one that actually drew the data model. Have you ever been in such a situation? That was a new one for me as well. I've seen a lot of things. This one was new to me. So that gives an idea about his involvement. He's now the product owner on one of my teams, which is good because it's easier to get things done in the whole organization. And so we couldn't store the application form into a relational database. It just didn't work. And he was like, yeah, well, it has to fit the model and that blah, 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 blah. I said, no, well, you can store things differently now. You don't have to have a relational database in place. You could say, for this particular component, which is called the application component, actually, we could say, you know what, if this is the application component, store it in its own data store. So we came to a policy that basically, as a guideline, we say every component has its own data store. Some of them, like there's a component for accounts, right? You have accounts and groups and permissions and stuff like that. That works really well on a relational database. So we put a DB2 under that. Some of them, there's also a product component. And it basically, it has services like, get me the conditions for this particular insurance product. And it gives back something. And since we're only supporting 2 products right now, I've ordered the team to hard code that. So it basically has a domain layer, and basically when you ask a question to the component, it says, okay, you know what, I'm going to spin up 2 instances and create 2 instances of this domain object, pass it back, and we're done. And the team, being very much into, you cannot get everything out until it's fully complete, they say, we can never put this out into production. They say, you know what, there has to be a database underneath, a relational database. You know what, we're going to create some object relational mapping, we're going to put Hibernate in place, and then we're going to stick it all in a database, and then we're done. And that's not the way it is, because I say, you know what, we only have 2 products now. The 3rd product we will support, we won't start supporting that until, I don't know, somewhere in 2015. So we don't need that right now. This is particularly the YACNI acronym, right? You all have the YACNI acronym, right? This is a very typical implementation of that. So I said, okay, we're just going to put it out hard-coded so we can put it into production. There's no database underneath. And they actually have a lot of trouble of actually getting that into their heads that that is a good way to do that now. And if we are going to support more products, we can literally get this one out and put the new one in, which might have a database underneath. Probably even a relational database. But we don't need it now. So the thing is, if you give every component its own data store and its own type of data store, you can actually look much closer to what type of database is ideal for this particular situation, right? So we've put in place for a number of these components that store structures like the application structure. There's also an agreement component that stores agreements. There's a dossier component that stores dossiers and stuff that's in there. That's basically rather unstructured data, especially for the application forms, which are usually incomplete until the user fully requests for the insurance policy. We have to be able to store them incomplete. So what we did is, under those components, we put under there a MongoDB database. Have you ever worked with a MongoDB? Who has worked with Mongo? Oh, quite a few of you already. You like it? Not yet. You will eventually. It is great for storing unstructured data. It is not great if you want to structure your data in a relational scheme. So you have to wonder, for each individual component, what is the most suitable way of storing stuff? Some of it might be hard-coded. Some of it might be better off in a relational database, such as account and groups and permissions and stuff. Some unstructured stuff is probably well better off in a document database, such as Mongo. And that's a good thing. And that is what Martin Fowler calls polyglot persistence. And I very much like that phrase. And that is a very good benefit of doing microservices. So there's lots of promises out there, right? We talk about we are building products, not doing projects. And I like that. Not because Scrum says so, because I hate Scrum. Yeah, I know. I wrote a book on Agile, and I hate Scrum. Basically for the same reasons Alan hates it. And it is scalable. It can be scalable, but there's lots of stuff you have to do for that. Decentralized governance, yes, you can do that. The risk of having that, saying, okay, we have all these individual components, is that you get something like, which I really don't like, which is code ownership. People will say, and I actually had this discussion last week with one of the teams, because my bigger team is split up into 4 smaller teams. And I wanted to add a service to, I don't remember what the component was. Oh, it was actually the application component. And we said, I want to add a service to it. And then the developers from the other team came to me and they said, well, this is our component. You should ask us. And I said, well, I need it now because the stuff we're building now depends on this particular service. It's just a very simple HTTP request that we wanted to get something out of this component. And I said, no, this is our component. So you have to put it on our backlog. And I said, okay, so when are you going to get around to it? I said, well, they looked at their backlog and they said, well, probably not in the next 6 weeks. I said, well, no way, because I need it now. So this is a risk of this decentralized governance, is that people will take or try to take code ownership, which is not something I favor. So then I looked at their backlog and said, well, this service is not yet on your backlog. So we're going to define it ourselves and we'll put it on our backlog. And since I'm the CDO of the company, I can actually do that, right? It's good being the CDO. I can actually change technologies overnight. By the way, guys, you didn't hear it. This is into the camera, maybe they're watching, etc., etc. So, and it can give you higher performance because it's very much smaller blocks and it's much easier to spin up multiple instances of a very small block. And it's technology independent, yes, for sure. Polyglot persistent, easy to build because they're smaller pieces of software. That is basically true. It does work. And they say, what's easier to test? Well, it depends who your testers are. Because what you do very much is test against the service, against the component, which means you basically, if you have a REST protocol in place, which we do, basically they have to type in the REST request, get some JSON object back, and look at what's in the JSON object. So they have to test things differently because they're not used to that. At least the testers in my company aren't. So it's easy to test, yes, if you set up everything. And especially if you have a landscape with multiple applications and multiple components. We now have like 15, and the number is growing fast, actually, because we're now building a component that creates PDFs. And we are going to create a component probably this month that is just about questions and answers, because there's lots of stuff in this environment that you say, okay, I want to have the questions with this particular product, the questions with this particular agreement, or whatever you might have. So we're going to build a questions and answer components that basically has like 2 or 3 different services. And we're not going to build an application to maintain those questions and answers yet, until we probably need it like in 5 years. We're just going to put it out there, put it in a database, you get some requests on it, done, right? And then we put it into production. That's the idea. So the deployment is easier than monoliths. Well, it is easier because you don't have to deploy this really, really big thing and have to test everything, but you can deploy small stuff. But deploying small stuff also has a big implication on how many of these pipelines should you put out. Do you have a pipeline for every component? Do you have a pipeline for groups of components? Do you have a pipeline for individual applications, etc., etc.? So yes, it is easier than to deploy small components than a monolith if you have the machinery in place. And that is not as easy as it looks like. So basically, when we started doing this, these questions came up, like, what is a microservice exactly? What does it do? Is there any guidelines on when is it too big? How many services does a component have? Do you even talk about components or just individual services? People seem to think, but I'm not sure about what it does in other companies, that it's only an individual service. It's just a REST request answered by some small piece of code. We don't have that. We actually have components. They're pretty small as well. They're not really big, and they usually answer like 3 or 4 or 5 different services. And then the way you build up these services is also you have to think about how to deal with REST. It's pretty much on the next slides, I guess, but anyway. So I'll talk about REST in a sec. So how do you define messages? How do you define your REST requests? Because REST all seems to be really standardized, it isn't. There is no standard way of building up REST requests. Because you can basically configure any URL to fit what you think should a REST API do. And if you look at the different companies that have REST APIs, like Twitter, like Facebook, like LinkedIn, whatever they might have, so the well-known names, if you look closely to what their REST APIs look like, they're all different. And that's okay, but you have to sort of identify the style that works best for you. And that also takes some time, but I'll illustrate that in a sec. So, and you have to build a deployment pipeline. I'll put one up. There's still a picture from Martin Fowler, the last one, I guess. So you have to find stages to deploy to, right? In my particular company, what we have now is what in the Netherlands we call that OTAP, which is OTAP. In English, that would be DTAP. So we have basically like 4 or 5 different environments. We have the developers write code on their local PC, actually. They will get laptops, as I advise to do that. And they run the test locally. They check it in. It goes into the development environment. So we want to kick off an automatic build that runs all the tests, builds all the code, and then puts it out onto the deployment machines, right? And then the other testers the other developers can look at it and see if everything still works. If that's correct, then we say, you know what, we want to push it to the T environment, the test environment, where the testers actually run tests on the services, on the web applications, etc., etc. And if that's done, we are going to move this stuff to user acceptance. And that's the tough part, because user acceptance, the user acceptance environment is not under our control. The development and the test environments are under our control. But then it moves to a different department in the company. And they work differently. They're not used yet to having small pieces of software being deployed. They're used to, once every half year, there's a lot of stuff that comes out at us, and we have to make sure it works. And they take 2 months to get it working, right? They configure the database, it then link all together, stuff, blah, 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 blah. Complex work. But it takes 2 months, right? And now we're coming up and we're saying, you know what? We have this thing here. Could you please deploy it so it works tomorrow? And they're unable to do that. So it's a cultural change as well. You have to change the culture in the way that your projects work together with your application maintenance. Well, people are rephrasing that to something called DevOps, right? It's more like the DevOps stuff. Is if you build it, you also have to run it, right? Stuff like that. Well, we're far from that at our current company. Hopefully, in a couple of years, we will actually get there. We actually we're moving to a new floor in the building, actually, where we are, the project that I run with the 4 teams is actually taking part of a really big room, and the other half will be taken up by the application management team. They're also going to move to the same floor in the same room as where we are, hopefully to get this process on the road much further. Right? So the thing is, with this new stuff, and you can probably say this for any fad. I probably could have done this for 10 years ago, about 15 years ago for Agile as well. But I'm going to take a sip of my coffee now. But basically the question is, does it really help us So are microservices really a stairway to heaven, or are they a highway to hell? Of course, this one is much wider, so there's much more people going to hell than to heaven. I don't know, I guess this is for Java. No, I'm not going to joke about Java developers anymore. And the thing is, we started doing this in January. So we're like 9 months on the road. I don't know whether it's this road, but anyway, we are on the road, and we are still learning. It's not like I can tell you the final advice on how to do this, but I can say, well, we've learned a lot of stuff, and we're still learning. Actually, we're learning every day. We're improving every day. But it's a lot of very, 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 very small steps. It's not something you can do overnight saying, okay, now we're going to move everything into microservices and we'll be fine. You won't. There's a lot of work involved in doing that. It's fun, though. I like it a lot. So, let me tell you a bit about this company I work for. So basically, we started out, and this actually comes from a presentation I did when I started there. This is basically the current situation. They have a mainframe. You ever seen one? I can actually literally, from my desktop, I can actually literally look at it. Because it's one floor down, and we have an atrium in the middle of the building, and I can look across the atrium, and it's one floor down. It's just actually standing there, right? So I can actually look at the mainframe, and they are going to replace it. Why? Well, basically, maintaining the mainframe costs them somewhere between 1 and 2 million euros a year. Right? That's, even in British pounds, that will be a lot of money, right? So they are trying to get rid of that. Basically also because the developers writing code to that, they are all over 60. So they're going towards the pension, and eventually there will be no more people maintaining this old code, which is written in C and COBOL and lots of other variations of that stuff, and nobody knows how to do that anymore. So we have to get the mainframe out because before these guys retire. They're nice guys, by the way. And they also have a wide variety of really big systems written in Java. So there's one system that does most of the work in this particular company, and they spent 5 years building that before the first deployment. And now it has been deployed in 2010 or something, and it's so inflexible that it's very hard to maintain it. So that's when I got in. They said, well, we have to do things differently now. We have to move away from this because we will get stuck. And they actually will. And they didn't have, so the technology is aging fast, and they didn't have any strategy on where to go next. So in the Netherlands, there's insurance companies that have mobile applications. If you drive your car into a tree, you can literally log into the application if you're not logged on already. Say, okay, this is my location with your GPS. Take some pictures, and that's it. You have just registered a claim for this particular insurance, for your car insurance, right? And that is really easy. That is actually what attracts new business. They haven't thought about mobile whatsoever. If you look at their public website, it looks like you're in the 80s. I haven't said that, guys, sorry. So it's rather old-fashioned stuff. So we had to move away from it. We had to get a shorter time to market because they try to introduce new products to the market. And it takes them at least a year to get them supported in IT. And that's way too long. So they had to move away from this. And then they said, you know what, we're going to change this stuff a bit. We're going to move to something which I like to call actually a micro landscape. Because it's not just the services in the back end. It's also the applications that we split up. We are not building big applications anymore. We are building single business process targeted applications. They're small. They have like 6 or 7 web pages. Bang, that's it. The whole application. And we can put it out easily, right? So we are moving to that. Which is tough, but I'll tell that along the way. So both of these both applications and components are really fine-grained, but still written in Java. So we don't use, well, we use a little bit of JavaScript and, of course, HTML5 and CSS3 and stuff like that, but they're all fine-grained and serve a single purpose. Both the components and the applications. And basically, we have to do that to be able to get stuff out. They have a really hard time getting stuff out into production. So what it looks like? Well, let me show you the applications first. We actually said, well, I'm sort of stating their application architecture. Each application serves a single process and targets a single audience because they have lots of different audiences. They have their own employees, intermediaries, the end customers, stuff like that. And they have different requirements. So we're building different applications, even targeting the same process for different groups of people. And they're really small, and they're always human-facing. So, and most of them will be responsive web, so we're doing Bootstrap, stuff like that, or on a native device like a phone or an Android phone or a Windows phone. Well, not yet. Or maybe even desktop applications, but they're all small, right? So this is our current stack. Actually, I wanted to do Angular as well, and I said, no, we're going to do JSF. You're not in the Java environment, so you don't know what it is. It's basically, it's the equivalent to ASP.NET web forms. It works. We're probably going to move away from it in the next 2 years. But that, again, is the ability, if you have these micro applications, that you are able to move away from the technology that you're currently using. So, too much text. I usually don't have that much text on my slide decks. But anyway, so they implement single business processes. We model these out in a technique that we call smart use cases. And I'll show you that. I haven't got a clue, by the way, what's the time? Could you have a watch?
10 past.
10 past. That means I've spent like 40 minutes? So I'm halfway, right? Oh, I'm really on schedule. That's good. They all implement a single business process. We model that out because this particular company does need some documentation. I'm not saying they are going to do whole loads of documentation. They did that before we started doing this. And now we're putting that into a model. And you might say, oh, you're using UML? Yes, we're using UML quite a lot. But that's old-fashioned stuff. I don't really care. It works. And I've written a book about it, so it has to sell as well. So it still sells, by the way. It's over 10 years old. But we are using UML techniques a lot. And if you listen to Simon will be here. Simon Brown will be here doing a workshop, I guess, on Friday. But I'm not really sure what Simon's doing at all. And he will say, you don't need UML for architecture. That's true. We don't use UML for architecture. We do use UML for domain modeling, for modeling use cases, stuff like that. Even some state chart diagrams, but we are not using it for architecture, by the way. So I agree with Simon on that. So, and we also said applications do never interact with a database or any other persistence mechanism. The only thing they can do is to reach out, in this particular case, over HTTP and REST, to a component or a set of components and get stuff from there and put stuff back in there. So basically, it's a very long way to get stuff on a web page and move it into a database. But it's a good way to do that. So they never interact. They only interact with services. That's the way we put it out. And we started doing that, and it sort of works. So we probably or might think about moving into, in the future, putting in a small message broker in place. Instead of all these applications targeting each other, right? Which makes goes for a lot of dependencies. So we might do this. We're not sure yet, because we wanted to get it working first, and after we got it working, we're going to improve on it. Not improve on it before we get it working, which a lot of companies actually do. So the reason we might be doing this is that I want to be able to move to something which we call an event-driven architecture. Because basically a lot of stuff that happens in the insurance companies is basically event-driven. Like, I'm a client and I'm changing address. So I'm moving to a new house and I need to change the address. Now, changing the address might seem like a simple operation. For an insurance company, it isn't actually. Because basically, a lot of insurance policies are based on where you are, right? So if I want to have, let's say, a burglary, I don't know if it's called a burglary insurance policy, so against burglary, I guess. What's that called in the UK? I haven't got a clue, right? Anyway, to protect the stuff in my house, depending on my address, depending on the city I live in, it's even cheaper or more expensive. And I live in one of the bigger cities of the Netherlands, which is way smaller than London. It has probably the same population as Iceland, which we lost 2-0 from earlier on this week. Anyway, that's my personal frustration today. You guys win everything these days and we lose. Anyway, so basically, living in my city, my insurance policy is much more expensive than if I would move to somewhere in the country, and it would be cheaper. So if I move from the city to the country, they have to recalculate all the rates for my insurance policies, etc., etc. So there's lots more to it than just saying, oh, you're going to change your address. Fine. So changing your address is something you could call an event. And you could say, an event comes into the mechanism, into the landscape, and a lot of these components and applications actually sort of subscribe. It's basically a PubSub mechanism. So subscribe to this event. Say, okay, if somebody wants to change their address, the car insurance component would probably want to do something with it. Our relations component would probably want to do something with it as well. The life insurance company doesn't really care. Policy doesn't really care, except that I have to print out a new agreement. So most of them will have to do something. So a lot of this stuff is actually event-based. And we're thinking of moving there, but first we have to get the current situation working. So basically, although it's slightly off, I turn it a little bit to the left. Blah, blah, blah. So this is basically, we said, you know, every of these applications, independent of the technology, has a similar architecture. So this is the basic architecture we set up. We have a presentation layer that has like stuff like all kind of UI controls, fancy controls for calendars, stuff like that, for putting in amounts, etc., etc. We have grids and pages and bootstrap stuff in here, by the way, which is really fun to play with. And we have a process layer, which is basically a bunch of use cases implemented in code. Literally, by the way. Every use case in the model becomes a use case in code. So we have a one-to-one link between the model and the code. And then there's the domain model. Of course, we use domain-driven design for that. Of course we do. So all of these applications have their own small domain model. Why? Basically because for any one of these applications, it might differ from what is in a component. So if I store an agreement in the agreement component, it might have a different structure than if I'm building up one from an application form in one of my applications. So they don't have to have the same structure. So there is no overall domain model for the whole company. They used to work with that, but it is so inflexible that I said, well, no way we're going to do that. Every application and every component as well gets its own domain model. Some of the components don't have a domain model at all, by the way. We just skip the layer because we just store it to the database, basically, to MongoDB. So we just store the JSON objects directly. And there's no validations on that we need the domain model for. But most of the applications still do have that. And there's the layer that says, okay, if this is your application, basically these two layers are your application, we need to get in touch with all these different services, which is somewhere around in the landscape. So here's code like gateways and service gateways that actually make sure that we can call on these REST requests and map the stuff we get back from the request, basically JSON objects, into what is the domain model, and then move it out into the application. So this is our, sorry, yeah.
Would it be fair to say that these services or components are bounded contexts?
Yes, I would say so, yes.
So we could think of a microservice as a bounded context in the context of domain-driven design?
Yeah, okay. Yeah, basically. Basically, if you look at it now, the stuff we now have around 15 components, but it will grow. If you look at it from a domain-driven design perspective, it's basically an aggregate. They're all based around one central domain object with some of that more stuff around it, but it's basically all one aggregate. So most of these components only have one factory and one repository, basically. They have a lot of value objects and a lot of stuff aside and enumerations and stuff and validation on top of it, a lot of business rules. But basically, most of these components have a single aggregate. But it's not a rule, right? It's sort of what we see happening. That doesn't mean that's always the case, but it's more or less true. Yeah. Good remark. Thanks. I have to put it in my slides. That's good. So if you look at in code, this is, by the way, IntelliJ, which, by the way, for you C-sharpies, it's interesting. If you move to the Java world, coming out of working with Visual Studio, which is really slow on this PC anyway. So on Visual Studio, I always work with ReSharper. I guess you all do, right? It's the most sensible thing to do. Always use ReSharper. And the funny thing was, when I got to this client, they were using Eclipse for Java development. And one of the external developers that they also got on board said, oh no, you have to move to IntelliJ. It's a much better tool. It is, by the way. And IntelliJ is built by JetBrains, right? So JetBrains also built ReSharper. So when I first lay my hands on IntelliJ and I started programming together with this other guy who came from Eclipse, and the funny thing was he couldn't find his way around this tool. And I, coming from a Visual Studio ReSharper combination, I knew all the shortcuts. That was so cool, right? I could do Control-Shift-N, and it will find my file. Control-Shift-N is by far the most productive shortcut I've ever seen. So does Control-N, by the way. So if you look at what it looks like, it actually has the same structure. We have a bunch of libraries, and this is basically my application. So you just can't see the top of it. I have to move this down a bit. Right. Oh, God. Oh, it sort of resets itself, right? I have to put the screen up, I guess. But this is the application actually. And it has like 4 different packages or modules, as it's called in Java, right? So here's the domain, the process, the services, and the web layers. And that actually has the same structure as in the application architecture diagram I had. I could show you the code, but then I have to kill you afterwards because it's a secret. Now, I have the code on my laptop. That's illegal, by the way, but I still have it on my laptop. So I can show you if I have some time left. So the next thing is the components that we have in the landscape. Well, they basically have more or less the same architecture, and they are the workers. So the applications do all the fancy stuff with UI stuff and jumbotrons and stuff like that. You have to have a jumbotron if you do Bootstrap, by the way. Nobody does Bootstrap, I guess, here, right? Talk to Shay tomorrow and ask him about the jumbotron. But the components do the actual work, or actually most of the actual work. So the applications basically all implement a single business process. And in that single business process, there are steps. Most of these steps require one or more services. They target one or more services to do the actual work. Like we have a component that actually does the workflow. Basically the human workflow. So if I store an application form while it's still incomplete, out comes a task. We actually say to the task component, it's called the task component, saying, okay, fire up a new task for this particular group of people, this department, that they will have to finish this, this application form. So it comes up into human workflow. So we have components for all these stuff. And they all have a single responsibility. So one of them deals with agreements. The only services it has is find my agreement by the agreement number, search for an agreement based on the person who's insured, and it also can save an agreement. And it puts the JSON structure you give it into the database. That's basically what it does. So it's a bit crud, but anyway, it works fine for us. Some of them have different stuff. Like there's a rates component that only calculates rates. And it gives back a bunch of numbers. A bunch of amounts, actually. So they all have a single responsibility. And the thing is, if you move from bigger components to smaller and smaller components, you get all these questions about, oh, if I'm firing up this process, am I giving it to this component, and then this component talks to the other component, or am I talking from the application to both of the components? Who is responsible for handling that piece of logic, right? And those are sometimes tough decisions. My girlfriend and I were sitting on the bus yesterday, and I got a message from the product owner on my team. And she's like, we have to do this and this process, and we are wondering whether it's better to move it to the agreements component, and the agreements component can talk to the PDF component, or the other way around, I don't remember. Or are we just passing in the agreement ID to the PDF component? And then the PDF component can pick it out from the agreement component. Are you still following me? I didn't, and I had to read it, right? And she was like, help, please come back. Literally, by the way, I can show you the messages, except that they're in Dutch. But, and I was like, I think the second one would be better. But we're still trying to figure out what the best way is. And it's different from situation to situation. So deciding which responsibility is done by which component or by which application is still very, very hard. Especially if you get them smaller and smaller and smaller. But it's worthwhile since it's scalable, etc., etc. So components have more or less the same architecture. I'll show you the picture again. So it looks the same, right? It's purple, it has 4 layers. Basically, it's the same. So it also has use cases. We say, because the way we use use cases, which is the last part of the talk I will get to, and I still have about 35 minutes to do that, so I'll be fine. Basically, we say that each service on a component is implemented by a use case as well. For us, there's good reasons for doing that, because we found ways to actually write the requirements based on the way you describe use cases. You could describe use cases, because there's no standardized way. That helps us test the stuff as well. So we're saying, okay, they also implement a bunch of use cases. So most of these components, they have service interfaces. The service interfaces call on the use cases. They use the domain model, if they have one, and go out into the backend. Now, the backend of a component can be a database. It could be a relational database. It could be a document database. It could also be that they're calling on other components. But the structure is still the same. I can show you the code later. So this is basically the architecture for the components as well. And they implement usually around somewhere between 1 and 5 different services. That's basically what we've seen already. And there's probably some of the components that we now have that we are going to split up. For instance, we have a product component that now contains questions and answers, and we are probably going to move the questions and answers into a separate component, which will be really, really small, with a really, really small database underneath, if there is a database at all. We could also put it in a JSON structure or an XML structure, just put it hard-coded out there. We could do that. There's lots of different persistence mechanisms that you could use on this. So what about communication between them? Well, the original architect they had on the team, he said, I want to do everything using WSDL and using SOAP envelopes and stuff. And I voted against that, and you should. It's not a bad mechanism, but it's let's say it's highly structured. That's a nice way to put it, right? It gives you a lot of objects. If you let your code generate from the WSDL calls and the definitions of that, you will get a lot of classes blown up into your application that you don't really need. And also, we needed much more flexibility in defining our REST APIs, our APIs. So we moved away from WSDL, and the developers were all very happy with that. The testers didn't know how to test it. They were used to testing WSDL and structures, and this is the XML you get out. And if that element is there, then we're fine. And they sort of had to redefine the way they work into doing basically the same, but then in JSON. So we moved to REST, and REST really works for us. But as I said earlier, it is very tough to decide on how to set up your REST URLs. And if I have some time, I probably have, I will talk a little bit about this stuff. That's why I put up this flip chart here. And I had to put it in a corner because it also has to be into my bounded context, so to say. And so for instance, but this is purely based on how we do stuff, right? It's not based on how Twitter does stuff or how Google does stuff or how Facebook does stuff, because they're all doing it differently. So basically, there is no definition. Basically, all the URLs we have start with the host. So we put up the host, right? In our case, the development, well, let's build this is the name of the project. It's just my host. Most of my services run on 8180. This is the host. The first step is you don't want to be dependent on where your host is, right? In this particular case, it's running in some Java application server, which you've never seen before, because you're not doing Java, right? Well, except for you, you've seen. So what kind of, we have a JBoss server, right? It's a JBoss 6.2 application server. In the .NET world, we don't have that, right? You're better off in the .NET world, believe me. Anyway, so we don't want to be dependent on that. So we pull that out into, we are getting this somewhere from the application server that it runs in, saying, okay, I'm here, good. So the next thing we did is saying, okay, so what's behind the first slash? Well, you don't know. Basically, the assumption basically is that you work on collections of things and on collections of resources, actually. So you could probably say, if you go to, I don't know, suppose I have books, suppose I'm Amazon, you might say books, and then I want to have book with the ID 318, right? This is valid REST API. This probably works more or less on Amazon. Or you could probably do it with the ISDN code or whatever. It depends. But in our particular case, we don't have that always. And the thing is, we said, you know what? First step we'll do, we put the name of the component out there. I'm not really sure whether that will actually stick, but we are doing it right now. So we put up the name of the component, like we have a product component. Right? And after that, you start talking about resources. Now, resources have a strange way of dealing with things. For me, coming out of a non-REST world, if you have been living in the REST world for a long time, you might think, well, this is too straightforward for me. So the thing is, most of the URLs are based on the fact that you want to get a particular resource. So if I want to get book 318 from the collection of books, this works. What it will do is we'll try to find book 318, which is basically a fixed resource. And if it's there, it will pass you back something, probably some JSON structure. If it's not there, so what do you get if it's not there? Right, you get a 404, basically. But, so we implemented that. We said, okay, we said, you know, if I wanted to get something out of a component, which I think should be there, we are setting up our URLs more or less like this. So we're saying, from product, I want to have the questions. This is my collection, actually, what you should say. And I want to have questions for a particular product. So the product is called ORV, which is Dutch. It's a life insurance policy. So this is basically the variable in this. So we're saying, okay, if I get the questions for the ORV, this is basically how I could put it up. The thing with this definition, we started using this. So this is a variable. It's much like from product 1, right? And then we said, well, probably this doesn't really work for us because in the end, if you put a number of parameters behind it to find a resource, let's say there's some other stuff in here, you will have eventually a hard time figuring out what the order of these arguments are actually. So what we did is we added a slight bit of stuff to the URL saying questions and then saying ID and then ORV or 1 or whatever you might have. So the full URL probably looks a bit like, okay, here's my host and then I have my component, product, questions, ID, and ORV. And this will get me the resource. And if it's not there, it will give me a 404. So you might think this is a bit too much descriptive for me. That could well be the case. But we needed a way to identify what the parameters were because we were not able to read them otherwise. I'll give you one example. One of the services calculated rates for insurance policies. And they needed to know the length of this particular insurance policy. So it ran for a number of years, right? So we put in 6. So it ran for 6 years. And then the rates were calculated, and it was really, really cheap. It was actually much cheaper than we thought they would be. To be more precise, it was 12 times cheaper than we thought it would be. So we were passing in the number of years that the policy ran. And they thought it was the number of months, right? So to get rid of that kind of stuff, you have to make sure that the URLs match. You could, of course, use... We created actually a value object for that called years and another one called months. So we're passing in years, and they're saying, oh, we're getting in years, and we want to map that to months, right? So we got rid of that kind of stuff between it. But they had to be more clearer for us. So we did it like this. And if you look at the code here, we created this very small thing. Let's say a somewhat more higher... Oh, I'm moving out of the box now. Oh, crap. Well, I'll move back in. No, I have to stick to that. Sorry. This is too much restricting for me. So we created a thing called a service locator. It's just a class we built to get a slightly higher level of abstraction. And it helps us build up the URLs. And if we started thinking about the URLs differently, we only have to change the implementation of the service locator class. So that made it easy for us. We were saying, okay, service locator, that component. Which component? Well, the product component, here's the questions. And I get in the ID of the product. And then I'm going to build up the URL. Basically, that's what it does. So the second thing about these URLs, you cannot see that on the code here, but there's a second way of dealing with parameters, and it's called query parameters. These are called path parameters. And your REST API will eat them up in your service, and they'll figure out what it is, etc., etc. But if you don't know what you are getting, you put in different types of parameters. They're called query parameters. So for instance, if I go talk to the relation component, I want to know all the relations, this particular relations, that live in the zip code, whatever, some zip code. I could probably do it like this, right? Zip 3544 DA, which is my personal zip code in the Netherlands. But that would say, if it's not there, I get a 404. And I don't want that because I want to be able to search it, right? It's basically finding stuff, finding all the people who live in this zip code. So you use query parameters. Query parameters are slightly different. You put, instead of this particular last one, you put a question mark, and then you say like zip equals 3544DA. And you put in an ampersand for the next parameter. This is different, right? This is for searching stuff. And then you might say, I'm getting a collection of relations back. Might be there's none. It might be there's 20. So this is a different way. So we use the same service locator, but you cannot see it on the unknown. There's my boundary. You cannot see, but we put in a second method here called find, and it builds stuff differently. Does that mean I have to be done, or they're early? I still have half an hour, right? Good. So we use this a little bit to get a somewhat higher level of abstraction on our REST APIs. And we made them a bit more explicit than most companies probably say that is the way to do it. But there is no fixed way of doing REST. There is no standard on that. So you have to define your own standards for that. There's different people doing it in different ways. So the next thing we said is we are going to do this model first. Model first meaning the applications and the components, the business process and the service they implement will be modeled down to the use case diagrams. If there is a domain model for this particular component, it will have a domain model. So that's the way we said we are going to approach this. And I'm actually going to show you this, just to have something, to have done something else than just show slides. I'm going to show a bit of the model. So I copied the model onto my laptop, actually. And this is just my travel laptop, so it doesn't really work as fast as my usual laptop. So if you look at the model, so we create, this is, by the way, is Enterprise Architect, which is a UML modeling tool. It can do much more than UML, but basically we use it for most of it. If you look at it here, this says these are the applications that we are working on. So one of them is actually the application, in Dutch, of course, and it has a use case diagram. It looks a bit like this. It doesn't actually fit the screen, though, because I have a very small resolution in here. So this is part of the diagram. So the main one here, which is called register for, or it's actually filling in an application. And it consists of a number of steps. This is actually a wizard. And these are actually use cases that model the different steps in the wizard. And they add some new stuff. So for instance, if I'm registering a product, I need to be able to show that I can find the person who's insured. And since in this particular company, the way it is that we cannot add relations to the database. They have to be, or to the relation component actually. They have to be already in there. It's the way they work. So we have to find the person who's insured just by ensuring this use case. So there's a bunch of these use cases. So together they implement a single business process. So every small application that we have actually implements one of these diagrams. No more, no less. I'll tell you a bit about the diagrams later on. And if you look at the services, we've more or less done the same, but the components have much easier diagrams. They usually only have, oh, I have one open right here. They only have a single use case. So this is the service interface, and this is actually becoming a class in the component, picking up the REST URLs, and we define the way it looks like here. So we're saying, okay, this is the way that it should be identified. It has one of the parameters will be something called the product identification. It's a get. And we used, you cannot see it here, but if I open it up, you'll probably be able to see that. So, oh yeah, you can see it here. We said here, this is a path parameter. So this is one that is formalized like the above, right? So that's the way we model this stuff. So for every component, there's a bunch of these really small diagrams. So this is my product component, and it has a bunch of resources, which is basically the second level in the URL. And for each of these resources, it has a simple diagram like this. Does it add value? Well, it does, basically because it defines how this use case is called and what this use case is actually doing. So we use the same way we describe and model the use cases in the applications to model them into the services as well. And we use the same way of testing the internals of this stuff as well. And it built up the same way. So that for us, that helped. So what's the next step? So let's move back into the slide deck. Oh, here's the same diagrams, probably. And the thing is, what we are expecting to happen, and it will happen because I've seen this at previous clients, is that we, over time, will build up, let's say, a large repository of individual services offered by our components and the way they are used into the applications, because there's traceability between the two types of diagrams. And with a previous component, actually the Dutch Railways, they build up in their application landscape, which was quite complex actually, much more complex than it is here. They build up a repository of over 500 individual services that the landscape actually offers. And they are now, so the first use case diagram you saw, they are building up new business processes just by picking the services from the catalog. And that is, for them, a huge benefit of dealing with this microservices stuff. So when we are moving into the same direction, we will have a repository of services that our components can offer. So here's the same thing, essentially. It's the same diagram, but only for the official colors. So you see, this is a bunch of the pages in the wizard, and lots of other pages in here. Now, I'm going to explain a bit about this approach of diagramming. And you can also see that they also become classes in code. So we have a layer supertype called use case. Doesn't really do much, but it is a layer supertype. Well, it does some stuff, actually. And this one is called vastleggen afleiding. It doesn't really mean anything in English, but it is one of the ovals on this particular diagram. Well, it's a bit more down here, but it is there, I can assure you. So this is basically the way we implement these use cases as well. So we can also test them in the same way. And of course, what we also do is that our applications and most of our components as well have a domain model and have all the facilities that come with domain modeling. Like for instance, if you look at, well, I was looking, oh, I have the same diagrams here. I didn't know that. Sorry. So here is, this particular one is one from an application. And here's the central aggregate class, and here's all the domain objects that are sitting around here. So we're all using all of the benefits, like stuff like using value objects. We use a lot of value objects instead of using the base types. And let me give you that recommendation. Please do, because value objects add a lot of value to how specific you can express yourself into your services and in your method names, etc. For instance, you all know what a value object is, right? I don't have to explain that. Anybody of you saying, okay, I really have no clue what a value object is? Okay, well, let me explain it briefly to you. So if you would have an email, what would you suggest to be the type of email? String, right? I'll beat you to it. String. So the thing is with string is that on an email, you know much more about this email address than that it's just a string. Because you know there will be an ampersand in it, there will be a dot after the ampersand. So it has some sort of, let's call it an expression. Basically, most people put it in a regular expression. What you don't want to do is every time you want to have an email on an employee or on a client or on an insured person or whatever it is, so it's everywhere. So every time you put an email with a string, that means the validation of that email address has to be somewhere in the object that it contains. And you don't want to do that. You want to have the validation for that particular thing inside of your email. So you create a type called email, as an example. This is just a very basic example, right? And you model the email as of type email. It's probably in here, right here. So here's an email address of type email, which means in the email class, because there is an email class, of course, which is a value object, the definition of how you validate that is inside of that. And it's only implemented once. And the nice thing that we discovered with working with the value objects here, because I've been promoting that for like I don't know what, more than a decade, I guess, is that they also help us to specify the REST URLs much more precisely. As I explained with the years and months example earlier, is we used to put in an integer, and then we didn't know what it was. Now we're saying, okay, in the URL, it's years. It is of type years. And in the service, it will pick it up, and it will try to unmarshal it into a years object, which basically means, oh, it's now in years. Same goes for amounts. They use big decimals for that. In the .NET world, you don't have big decimals. We don't have big decimals, right? In C#, no. So they use this really strange, which is not even a number actually, and they sort of grabbed it together. So using value objects in this world is actually very helpful to be much more precise about your URLs and your REST APIs as well. That also means, by the way, that you will probably end up with a collection of these objects, of these value objects basically, and some enumerations as well, that are used throughout your landscape. So they're used in your applications, and they're also used in your components, which means you have to pull them out. So we started pulling those out into a separate library, which is now called the name of the insurance company, .core.domain, blah, blah, blah. So they're in there somewhere. And all of these applications and components can use it. Also, you have to be aware that that library cannot grow too big, because otherwise you get a lot of dependencies that you don't want. But there's a trade-off there in reusability and not having all these dependencies there, right? So I'm going to skip through these diagrams a bit. Lots of them out there. See, this is a library of all of these value objects that we have, and it grows a bit into IBAN numbers, which, well, of course, you know all that, and amounts and whatever. And we have a thing called a pair value object. It's interesting stuff. URLs even, and phone numbers, etc., etc. So it grows a bit. And we reuse that all the time. Not going to talk about this one. So I'm going to try to explain a bit about these requirements and use cases now. So basically, we start up with some design up front. So I'm not saying do all of your design up front, but it's not a bad case to do some design up front. Of course, we do use Agile, but I'm going to skip the Agile part for this talk a little bit, is you don't know exactly what your requirements will be. You don't even know what services you will have. So this insurance company started out with saying, oh, we need that service, and that service, and that service. And I said, how do you know? They said, oh, well, we'll probably need them in the future. I said, well, you don't need them now. So please don't define them. Because basically, if you find them now, and we'll build them, and you will only need them in about a year's time, they will have changed. So don't build that. Don't even model it, right? But we do need to model some stuff. Especially when we build an application which implements a business process. As soon as we start that, that's building on that small product, we model out the use cases. So the thing with these use cases is, and I'm going to skip a bit of the slides here because I'm not going to show you the full approach, because I can literally talk about that all day. And I do, because I do give training courses on that stuff. So this is a picture that comes out of a book by Alistair Cockburn. It's called Writing Effective Use Cases. And it doesn't only adhere to use cases, it also is valid for if you use user stories as well. Although I don't like user stories, because to me, they're too unstructured. But the levels is a good thing. When I first discovered this picture, like in '95, I was like, what on earth is this? And it sort of got to me. The thing is, most requirements in projects are written down at what Alistair calls C level. It's also called user goal level, which basically means a requirement at this level satisfies a single user goal. And that is a good thing. Like, register for an insurance product, get a subscription to a magazine, get a mortgage, whatever you do. So those are all requirements at this particular level. But it's not a really particularly helpful level if you build software. Because they can be really, really big. So like the change address, if I would do change address at this insurance company, it would be huge. I would have to do a whole lot of software, which I don't want to do. Otherwise, log in to an application or to the main portal is also a use case at that particular same level, which is much smaller. The worst one I've ever seen was do the quarterly billing. That was at a Dutch pension fund, and I came 1.3 million. Right? And they did it every quarter. So it took us 1.5 years to build. That's too big. So we started splitting that up. And we split it up into something that is called, in Alice's model, fish level, or sub-function level. And that is precisely what we do. So I'm going to skip through these slides a bit. If you want, I can explain them later today or somewhere. And we'll end up with these diagrams. I'm going to show you the second part of the approach, which is basically looking at these different levels of granularity. So if you have, for instance, if you're building a call center application, you could have a use case called register call. It does the whole shebang, right? It says, okay, somebody phones in, and they say, okay, I'm this customer, I just bought a washing machine at your company, and does that work well? Could you please come over and fix it, blah, 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 stuff like that, right? And you could, if you try to figure out what's all inside of that process, it's pretty much, right? So if you build it like that, you would end up with a document of over 100 pages. I once did a use case at a bank, an international bank, that had 65 pages. It had a basic flow of 12 pages. It had over 100 alternative flows. So it was impossible to test. And it had like 13 forms in there. And in total, I said already, it was 65 pages. The name of that use case was change address, which is pretty much a usable level use case for that company, but it was too big. So you can't build that stuff. So what we did is we split it up into smaller little overs. And all of these ovals are actually use cases as well, but they sit at sub-function level. So here's still the register call use case, but it calls another use case called search customer, manage customer, search call, search the product, and define the first activity. Those are basically also use cases, but they sit at the sub-function level. And the good thing about that is that instead of creating a thick document, you can actually put it out into a diagram.
So it's much more visual approach to doing that. And if you work with users a lot, they like visual approaches much more than they want to read text, right? You're all that. So the granularity of these smaller use cases, so these, is basically all the same. They're all similar in size. And they're small, which means you can all build them and test them in a relatively short period. So maybe in half a day, maybe in a day, maybe in 2 days. But it's not much longer than that. So you can build it within your sprint, if you use sprints at all, which I think you don't need to. Anyway, you should read my blog on that. And it's a good unit of work we discovered in an enterprise project, in enterprise agile projects that is. Also, reuse becomes normal because there's lots of reuse in these really small use cases. So we use them a lot to, for instance, model out these services as I've shown you, and pulling them out from the service repository and putting them out onto the business process. So every business process we implement, which will be one micro application, has a single root use case, which is called a usable level use case, which is basically one like that, and a whole bunch of these small use cases sitting on the right side of it. So I'll show you some examples of that. So basically, what we found out is that if you start working on the bigger use case, so what is a good point of pulling out these smaller use cases? Well, we've identified a whole bunch of these guidelines, and this is just a subset of it. Like, okay, if you think the smaller use case can be reused, please do that. If you think your use case has more than one form attached to it, please split it up. So each use case handles one form. If there is complex calculations, like interest and rates and whatever you might have, and pre-pensions which add ones, it's a use case. If you have interaction with others, please move the interaction out. So all these services become use cases as well. And we started doing that, and we created diagrams like these. This actually comes from the Dutch railways, actually. So this is basically, this is the main process, and it has a bunch of screens attached to it. This is basically the portal of the Dutch railways. So if you've been to the Netherlands and you try to figure out the timetable, you've been on these pages. And there's a bunch of, this is actually middleware, because they use an SAP service bus. And there's some VPN stuff in here. And these are all individual services that are delivered by a lot of different applications in their landscape. And they all get together into one business process. So every time they compose a new business process, they set up a diagram much like this. And you can see the reuse. If you use a good tool for that, and this again comes from an enterprise architect, it is a really good tool to identify reuse. And you can see that this particular use case called select contact, which is basically the same reduction in English, oh, it is in English actually, is used in a whole bunch of other diagrams as well. So you see the reuse in the model. And the same goes if you do services. That becomes even better. So then we identified that there's lots of different sort of standardized types of these use cases. We said, you know what, there's a whole bunch of them that actually deal with front-end stuff. Like, I want to be able to manage an instance of a domain object, I want to be able to search through my domain objects, I want to be able to select them from a very limited list, or I want to have a list and then maintain them on the right side. So basic UI patterns that you have. So we put them out into use case stereotypes, as it's called in UL. So use case stereotype is basically, diagram here is basically the stuff you see here, right? It's a search, a master detail, a view, a managed, or a file import, a file export, lots of stuff you can define. And the list of this stuff grew actually. This actually comes from a website called www.smartusecase.com. And there's a whole list of them, and it grows, and there's lots of standard types for services as well. So we have things like read and write and aggregate and calculate and stuff like that. And it helps us to model, a bit standardize the model. So, here's another example. Again, this is the same use case. So, when you start implementing this stuff, you soon realize that these use cases have a life cycle of their own. And this is one of the things I don't like about Scrum. But I will be talking more about this stuff tomorrow. The thing is, if you use Scrum to manage a process, and you put up the default Scrum task board with to do the progress done, you do not see the progress, right? And we've identified that use cases have this life cycle, and we use this life cycle to manage the progress of our use cases. So it goes through some analysis and design. So you write down the basic flow, the alternative flows to the use case. That's basically the design. And we do that in workshops. We call that those design sessions. So the product owner, the client is there, the tester, the developer, and we have analysts still on the team. Together they work on that use case. So they all know where it goes from that point in time. So we build it, and we implement it, and we create the test design, which is basically a lot of work. So we build it, we test it, and sometimes there's rework. It goes back into the cycle, or we get it accepted by the client. And that's basically the life cycle. And you can put the life cycle out onto your dashboard as well. So instead of having these really stupid 3-column strong dashboards, you can have more, it's more like, you'd probably call this a Kanban board, which has different stages. So each of these little yellow post-its is a use case. The purple ones are actually technical stuff that we also need to do. So here's the same steps. And the blue ones are actually the people who are working on all of this stuff. So this is our flow. And we work on it continuously. Right? It grows continuously. If a use case pops up on the backlog, we put it on the backlog, and it goes through the same cycle. So we are slightly also losing the sense of having iterations, because we don't really care, because we're building these many applications or a service on a component. And it just needs to go through the flow and be at the end, independent of whether you can do that in a 2-week cycle, which is pointless, basically. So we started doing that. So this is basically the way people used to do that in use case. You write it down into a document, have the base flow, the alternative flows, etc., etc. And we started automating that. We started to use Enterprise Architect for that. So this is not an Enterprise Architect commercial. I don't have any involvement in the developer of that, but they have a nice thing that you can actually do. So what you can do is, you can write down the scenarios, basically in some slightly more structured form, because you do that in a Word document. You've probably all done that. You lose the numbering, right? You enter a step in between, and some other alternative flow has to get back to that step, so you have to adjust all the numbers there, etc., etc. It does that for you. But it does a bit more for you, actually. So it also generates out then the documentation. This is something we use a lot. But it goes a bit further than that as well. Also, this is, by the way, in between we use wireframes. We build them up into in Balsamic, which is a tool that easily describes the UI. And we put it into the documentation, into the model, and so it's part of the model too. I'm going to skip this one. So basically, when we started out, if you have a base flow and some alternative flows on your use case, there's lots of different scenarios that you can run through your use case. People used to do it by hand. This is actually a picture I took from one of the testers earlier in one of my teams. He drew all these diagrams by hand. And the funny thing is, we discovered that Enterprise Architect, you should turn it like 90 degrees, is able to generate those diagrams for you from the use case description. That saves a lot of time for our testers. So we can just figure out, okay, what's the different scenarios that you can use to run this through. But then the next step was, an Enterprise Architect also could do that for us. So it generates even the test scenarios. So the work that remains for our testers, and testing is always the hard part here, is that they have to write down all the test cases that run through. Which is, well, I'm not a tester, I never will be, because you have to do this, right? You have to do all this manual testing. And although we do a lot of automated testing, there is no way that you can get around having no user testing at all, or no testers at all in the project, because you still need them. So basically that's it. I'm going to skip the agile part. I'll leave that for tomorrow's talk. But I want to leave you with some conclusions, some stuff. This is in the slides tomorrow as well. So this is my team. Oh, this is even the CEO of the company. I'm not sure I like it if I put this picture up on here, but anyway, some small recommendations because I have to leave you guys now. The first thing is, if you start doing this, keep it small. What I've seen in a lot of companies that move into this direction is that they are doing this, right? They are building a car. Basically, we're saying, build a wheel first and then build a second wheel. So you have nothing in production until the end. It's much better and easier even to say, well, you know what, we'll first build this cable because it varies, right? I don't really care if it takes 5 steps to select the intermediate in my process for creating an application for insurance. If I have to take 5 steps, but it works, it's okay. And the CEO says, no, it can be much faster. We can do that in 2 steps, in 2 clicks. I say, yeah, but it works now. Just put it out first, and then improve on it. Then build the next one, and then build the bicycle and the motorcycle, and then build the car. We'll build it step by step, and put it out through the full cycle. So we got up to this. So first, we have to do it. We have to build it first. It has to work. It has to run. And if only after we've done that, we pick on the next piece. Or we start improving on the first piece. But put it out first. And you can always do it better in the end. Not try to do it the best way or the perfect way first time around. This is particularly hard at my current company. You either have nothing or it's too perfect. There's nothing in between there. And a lot of companies work like that, I'm afraid. And the last thing is,
Rest seems to be easy if you start using it. It's not. It's far more complicated than it looks, especially if you go into marshalling and unmarshalling stuff. That is a lot harder than you first expect it to be. So that's basically it. I hope I'm still on time. I usually try to. This is actually, if you feel like reading a book on Agile, which is slightly different than most of the other books, sort of beyond Scrum, you see. I hate it. Did I tell everyone why it's called? This is basically, if you type in this URL, type in this password, and type in this really unreadable code, you get, I think, a 30% discount on the book. So I'll leave it here for a second so you can take a picture of it. Please don't share it with the whole world, because otherwise I won't make any money. Okay, so this is the last slide. If you feel the need to get in touch, this is my email address, my Twitter account, which I usually respond to much faster. Thank you for indulging me in this really, really warm room, and I hope to see you back tomorrow for another talk.